We're going to talk about our last equilibrium expression, and that's the equilibrium expression of solubility. And that involves a solute dissolving in a solvent. KSP is the solubility product constant. It indicates how soluble the solid is in water. Unless you've been told the solvent, otherwise the solvent is always water. If you have a KSP that is small, the solute is not very soluble. If you have a KSP that's large, it is very soluble. I have seen KSPs in this order.
Oh, that's
Okay?
nice.
That would be like rock soluble, okay? A rock is not very soluble. It will dissolve, but not a whole lot. Even substances that are considered insoluble will dissociate to a small degree. Barium sulfate is in equilibrium with its ions in solution, the barium ion and the sulfate ion. So the KSP is equal to the molar concentrations of each one of the ions in solutions. And just like anything else we've done, the exponents equal the coefficients. However, you must remember that we leave solids, because their concentration is constant, out of the KSP expression. So for this equilibrium expression, the KSP would be written this way. So write the KSP for the following. I would like to know the KSP for calcium phosphate. KSP would be equal to the calcium ion raised to the third power and the phosphate ion raised to the second power. Hey, wait a minute, I don't get that. Well, that's because calcium phosphate, 1 mole of calcium phosphate will break into 3 calcium ions and 2 phosphate ions. Okay, now I get it. Do the silver chromate, please. Calcium phosphate is added to water at 25 degrees C until equilibrium is established. If the calcium ion concentration is 3.4 times 10 to the negative 7th molar, what is KSP for calcium phosphate? Okay, calcium phosphate would be in equilibrium with its ions. So far, I'm good with that. The KSP is this value here. Now, they told us what the calcium ion concentration at molarity is. Okay, now we need to know what the phosphate concentration is. Well, we can do a little stoichiometry based on here. I would like to know the molarity of the phosphate if I'm given the molarity of the calcium ion. Right, so for every 3 calciums, I have 2 phosphates.
Isn't that supposed to be negative 7?
Yeah. So my molarity of my phosphate would be 2.28 times 10 to the negative 7 molar. I can put that into my KSP expression. KSP is equal to my calcium, 3.42 times 10 to the negative 7 raised to the second power times 2.28 times 10 to the negative 7. Third. It is to the third. Raised to the second power. When I do that, I come out with a itsy bitsy number, which is 2.08.
2.08 times 10 to the negative 33.
Yeah. Would you stop that for a minute? Somebody walked off of my notes.